Welcome to Kenton's videos. Enjoy the video.
You begin by choosing a clear target and collecting representative data. This is critical. Once you have balanced, labeled samples, split to train/valid/test immediately. Make sure to configure Python 3.10 inside a virtualenv and install pandas, scikit-learn and either PyTorch or TensorFlow with GPU support. Next, pick a baseline model, logistic regression or a small neural net, so you measure actual gains. Start coding the preprocessing pipeline now. Cleaning, normalizing, and encoding features before any heavy model tuning. You move into training using a repeatable pipeline. Batch, augment, and shuffle data to avoid leakage. Once training starts, save checkpoints and monitor loss and validation metrics every epoch so you catch overfitting early. Make sure to normalize inputs and apply scheduled learning rate changes. They often yield large improvements. Then tune hyperparameters via grid or random search. Focus on learning rate, batch size, and regularization strength. Log every run with timestamps and metrics, so comparisons are accurate and reproducible when you iterate. You finalize by exporting the train model along with the exact preprocessing manifest and configuration. Choose ONCs or the framework's native saved model. Once exported, deploy to a staging environment and run /B tests while monitoring latency, throughput, and real-world accuracy. If production drifts or errors appear, retrain using recent labeled data and audit the preprocessing pipeline for feature shifts. One key troubleshooting tip: when performance collapses, first check data schema and normalization. Mismatched scales cause the majority of failures, so verify inputs end-to-end.
Thanks for watching. Consider subscribing if we helped you.